Our topic of discussion today is linear and quadratic inequalities. Now, in most cases, you'll usually find only one or two questions relating to this in your exam for term 2, 3, and 4. In term 1, you might find more of them as there's not many topics that you cover in term 1. But this, basically the concept of inequalities, think of equations. If you understand equations, you'll be fine with inequalities. The only difference is that instead of using an equal sign, we will use a greater than sign or a less than sign, okay? And there's one additional rule. That rule is, I'm sure you guys are familiar with an equation whereby you divide by the coefficient, right? So let's say you have 2x is equal to 8, for example. When you're dealing with an equation, you usually divide both sides by 2, thus leaving you with x equals 4, right? However, when you are dealing with an inequality, when you divide by this coefficient, keep in mind when we talk about a coefficient, we are talking about the number that is in front of the variable. So in an inequality, when you divide by a coefficient, there's two cases that can occur. In case number 1, if you are dividing by a negative coefficient, let's say you are dividing both sides by -2 or -3 or -1, whatever value it is, if you divide both sides by a negative, you have to change the direction of the inequality. Let's do an example of that. So let's say you have 2x is greater than 6. Now, let's make this negative. If we divide both sides by -2, that means that the direction of that inequality sign changes. So we will then have x less than -3. Do you notice this direction? It changes. Initially, the opening was facing left. However, when we divided by the negative, the direction changed and the opening was now facing right. So always remember that. If you divide by a negative in an inequality, you flip the inequality sign, you change the inequality sign. It must face the opposite direction. Now, that's the first case. Let's have a look at the second case. Our second case is if you were to divide by a positive coefficient. So if you divide both sides by a positive value, you don't do anything. There's no changing of direction. There's no changing of signs. If you divide by something positive, it stays as is. Okay, so those are the two cases. If you divide by something negative, you change the direction of the inequality sign. If you divide by something positive, you leave it as is. For example, if we look at an example, if we have 2x less than 10, if you divide by something positive, you end up with the exact same direction, okay? So those are the two rules. Please make sure that you understand them and you remember them. Guys, if you are going to have a private conversation, please make sure that your mic is muted. So those are your two rules. If you divide by negative, you change the direction. If you divide by a positive, you keep it as is. Now, let's have a look at our first question. We've got a linear inequality. What do we mean, or what does the word linear mean? Think of your linear functions, right? You know that when you are dealing with a linear function, the degree is 1. When we talk about a degree, we are talking about the highest exponent. So when you're talking about a linear inequality, it means the degree is 1. The highest exponent is 1, meaning there is not going to be x squared or x cubed. It's just going to be x. So that is a linear inequality. When you are looking at a quadratic inequality, the degree is 2, meaning the biggest exponent is going to be 2. You'll have x squared. Okay. Now, let's have a look at this question. So we've got 4 into x minus 3 greater than or equal to 2 into x minus 10. Now take a note at that representation of that inequality sign. It's equal to as well, meaning you include that value. It's inclusive, right? So if we were to solve for this, all we are going to do is on the left, distribute the 4 into the bracket. On the right, distribute the 2 into the bracket. So we now have 4x minus 12 greater than or equal to 2x minus 20. All we did was distribute the 4 and 2 into their respective brackets. From here, think of a normal equation. Move all of your variables to one side and all of the constants to the other side. A constant is a value or a term that does not have a variable, meaning that negative 12 and negative 20. Those are constants. So we're going to move 2x to the left. It'll become negative 2x. Keep in mind your normal equation rules still apply. If you move a term from left to right or right to left, as long as it moves from one side to the other, it means that the sign changes. So because 2x was positive on the right, when you move it to the left, it is going to be negative. So from here, we then move that negative 12 to the right, and that becomes positive 12. From here, all you now need to do is simplify, add up the like terms. So we have 4x minus 2x, and that gives us a value of 2x. On the right, we have negative 20 and positive 12. That gives us a value of negative 8. So from here, we now need to divide by the coefficient of x. We need to divide both sides by 2. So we have x and we have negative 4. But who can tell me, is my inequality sign going to be facing the mouth, the opening? Is it going to be facing left? This is option number 1. Or is it going to be facing right? This is option number 2. Who can tell me? Are we going to go with option number 1 or option number 2?
Number 1.
Option number 1.
That is correct. So whoever said option number 1, that is correct. Because we are dividing by positive 2, we are dividing by something that is positive. We are now going to keep the sign as is. It is only when we divide by a negative coefficient that we change the sign. Okay. Does anyone have any questions relating to example 1? Is there anything you do not understand? Anything that was not clear? Something that you need me to repeat? Okay, so if everyone's okay, let us move on. So we now have example 2. If you notice, example 2 is quite similar to example 1, but there'll be something that's slightly different. You'll see as we do it. Now, the same rule applies. We're going to distribute this negative 4 into the bracket. So that gives us negative 4x plus 12 greater than or equal to 2x minus 24. From here, we move all of the variables to one side, and we move all of the constants to one side. So I am going to move 2x to the left, giving me negative 4x minus 2x greater than or equal to. I'm going to move positive 12 to the right, giving me negative 24 minus 12. From here, we have negative 6x greater than or equal to negative 36. Now, I need to divide by the coefficient of x. I need to divide both sides by -6. So we then have x and we have +6. Now, who can tell me, is it going to be option number 1 or is it going to be option number 2? Which is
Option number two.
That is correct. We are going to go with option number 2 because we divided by a negative sign, meaning that the direction of our inequality changes. So that is our answer. X less than or equal to 6, meaning 6, 5, 1, 10, 1, 0, -10, -100. All those values are possible solutions for this example 2. So that is example 1, that is example 2. All you need to remember is that when you divide by a positive coefficient, the direction of the inequality stays as is. When you divide by a positive coefficient, the direction of the inequality stays as is. When you divide by a negative coefficient, the direction of the inequality changes. Now, let's have a look at example 3. Got fractions in example 3. Now, there's a few ways that you can do this. One option is that you can use three-way multiplication to turn this into one fraction, then cross multiply, then start solving for y. That's one approach. A second approach is you can use what you learned in primary school. I'm sure you remember adding up fractions in primary school, right? And when you add fractions, you multiply by the denominator of the other side or the other fraction. So you can use a similar approach in this question. That's one option. A third option is to move one of the fractions to the other side and then cross multiply. So I'm going to use the third option. I'm going to move that y minus 6 all over 3 to the right. After that, I'm going to cross multiply. So we have 3y plus 2 all over 4 is greater than y minus 6 all over 3. Take note that this fraction was originally negative, right? Once we moved it to the other side, it became positive. From here, we can now cross multiply. So that 4 can get multiplied with the right side, and that 3 can get multiplied with the left side, giving us 3 into 3y plus 2 greater than 4 into y minus 6. From here, we end up with 9y plus 6 greater than 4y minus 24. Okay. All we now need to do, just as we did before, move all our variables to one side and all the constants to the other side. So we have 9y minus 4y greater than negative 24 minus 6. That then gives us, let's see, we have 5y greater than negative 30. Now we need to divide both sides by 5. So negative 30 divided by 5 gives us negative 6. So we therefore have y greater than negative 6. That is it. The only trick for this particular question was to identify which is the best method to turn that fraction, or basically to get rid of the denominators in the fraction. Whenever you are dealing with an equation or an inequality, your goal is to get rid of the denominators. From there, you can just solve as you normally would. So, before we continue, does anyone have any questions relating to example 1, 2, or 3?
No, sir. No, sir.
Okay, so let us continue. Now, example 4 is kind of similar to example 3. So, do you guys want to have a look at example 4, or do you want us to skip?
Look at.
Okay.
Look into it.
Okay, so let's have a look. Now, if you notice, we've got two terms on the left and one term on the right. So we need to identify the best approach to try and get rid of this 3. We don't want that. Remember what I mentioned earlier? When you have equations or inequalities, always get rid of that denominator if it's a constant. So one option is we can multiply each term by 3. So that 3 cancels that 3, and you'll be left with y plus 5 plus 3y less than 3. This is one option. A second option is to use 3-way multiplication. So we know the y is over 1, right? Any fraction that does not have a denominator, or rather any number or variable that does not have a denominator, has an invisible 1 as a denominator. So you can cross multiply and then multiply the denominators. That is what is known as 3-way multiplication. The purpose of 3-way multiplication is to find a common denominator, to turn 2 fractions into 1 fraction. That is the goal of 3-way multiplication. So from here, we'd have y plus 5 plus 3y all over 3 less than 1. From there, we can cross multiply, and that would get rid of our denominator. That is a second option that we can make use of. Then a third option that we can use is to move the y to the right, making y plus 5 all over 3 less than 1 minus y. Once we move that to the right, it becomes over 1, and we can then cross multiply to get rid of the denominators. So I don't want you to get confused between cross multiplication and 3-way multiplication. Cross multiplication works when one fraction is on the left and one fraction is on the right. That is the only time you can cross multiply. You cannot cross multiply if you have a over b plus c over d equals 1. You can't cross multiply if you have something like this. You can only cross multiply if one is on the left and one is on the right. Whereas with 3-way multiplication, the purpose is to get rid of the denominator. So you can use 3-way multiplication in this circumstance over here with this a over b, because everything is on one side. So you can use 3-way multiplication when everything is on one side or when the 2 fractions are on one side. But you cannot use 3-way multiplication when one is on the left and one is on the right. So I'm going to repeat that once more. You can only use cross multiplication when one fraction is on the left and one fraction is on the right. You can only use 3-way multiplication when all of the fractions or those 2 fractions are on one side. Okay. Now, what method do you guys want us to use? Are we using 3-way multiplication, cross multiplication, or are we moving the y to the right and then cross multiplying? Which option do you want us to use?
The first method.
The first method. The third
What
one.
was the first one? Was it 3-way or cross?
Yes.
3-way, okay. So let's use 3-way multiplication. So when we're using 3-way multiplication, take note that this y, because it doesn't have a denominator, we can put it over 1, because we know that y divided by 1 is still y, right? We're just including the 1 to make it easier for ourselves. So we're going to multiply this 3 with y. We are going to multiply the 1 with that y plus 5, and then we are going to multiply the denominators. So that is three-way multiplication. Bottom to right, or rather you can say, what's a nice way to put this? We can say bottom on the right to top left, bottom on the left to top right, and then the bottoms, multiply the bottoms. So basically think of cross multiplication, but you also multiply denominators as well. So I'll do a quick example on something that's much simpler. Okay, so if you have A over B plus C over D, and you want to use cross multiplication. So from here, we multiply the purple arrow first. So A times D, that'll give us AD. Then we multiply the red arrow, B plus, or rather B times C, and that'll give us BC. And lastly, we multiply the denominators. So B times D, that gives us BD. Before I continue to the actual question, who does not understand what we've done with this three-way multiplication? So everyone's okay? Okay, then let us continue. So just as we did in that example, we're going to start with the purple arrow first. So that 1 times y plus 5, that gives us y plus 5. Then we have the red arrow, which is 3 plus y, that gives us 3y. From there, we multiply the denominators. So 3 times 1, that gives us 3. I'll color code it so that when you have a look at this later and you forget what we did, you can still try and figure it out. So the purple highlighted stuff is the purple arrow. The red highlighted stuff is the red arrow. And then obviously we have our denominator area. Okay. Now, before I continue, does anyone have any questions with what we've done so far? Or any parts of this that you do not understand? So everyone's okay. If you have a question, you don't have to feel shy. You can always unmute yourself and speak up. Confidence, you have your mic unmuted. Do you have a question?
No, sir.
Okay, then let us continue. This is where we are currently. We need to try and get rid of that 3 at the bottom. Remember what I mentioned earlier? Our goal of equations or inequalities, whenever we see a denominator, is to try and get rid of that denominator. So which method are we going to use? Are we going to use three-way multiplication, or are we going to use cross multiplication to get rid of that denominator? What's our next step? Three-way multiplication or cross multiplication? One is right, one is wrong. Who has an idea?
So can I ask a question?
Yes.
So didn't we already use the three-way multiplication by getting our second step, our first step, the y plus 5 plus 3y over 3? Didn't we use like the three-way multiplication to get that?
Yeah, we did use three-way multiplication. So my question is to go to the next step. Let's call this step 1. Let's call this step 2. So we used three-way multiplication to go from step 1 to step 2. Remember, three-way multiplication was not the only option we had available for step 1. There were 3 options that we discussed. Now, for step 2, there's 2 options that you can use. I'm not going to mention both options. I'll mention one. One option is to multiply by 3 on the left and multiply by 3 on the right to cancel this out. That's one option. A second option is you can either use cross multiplication or you can use three-way multiplication, but one is right, one is wrong. It could be that three-way multiplication is right and cross multiplication is wrong, or cross multiplication is wrong and three-way is right. So one could be right, one could be wrong. Who has an idea of which is the correct method between the two to use to take this to the next step, or to step 3?
Cross.
I think
Cross multiplication.
Yes, so whoever said cross, you are correct. So we would now use cross multiplication to take this to the next step. There's a quick thing that I want to ask. There was a point in time whereby I wrote some stuff down here, and I was talking about the differences between cross multiplication and three-way multiplication. When to use which and when you are not allowed to use one of the methods. Was I muted at that time, or did you guys hear that? If someone can unmute yourself and speak up.
So I think you were muted at the time.
I was muted, okay. Then did you guys also hear the explanation when I was highlighting these things and talking about how to use three-way multiplication, or was I also muted at that point?
no,
We
fine.
did
We're fine.
understand.
You had that. Okay, so let me just quickly repeat that explanation on when to use three-way multiplication and when to use cross multiplication. So let's say we have this equation, right? So we have A over B plus C over D. Let's actually make it equal to. So we have this equation, A over B equals C over D. Now, in such a circumstance, or in such a situation, you can use cross multiplication, but you cannot use three-way multiplication. So if you have one fraction on the left and one fraction on the right, you cannot use three-way multiplication. Three-way multiplication is only to be used when both of your fractions are on one side and you are trying to find a common denominator. You are trying to turn those two fractions into one fraction. An example of that is if you have A over B plus C over D, and that is equal to, let's say, E, for example. In this situation, because you have two fractions on one side, you can now use three-way multiplication, okay?
Yes, sir.
I'll repeat once more for those that did not hear. If you have two fractions on one side, you can use three-way multiplication. The goal or purpose of three-way multiplication is to turn two separate fractions into one fraction. That is three-way multiplication. It's finding a common denominator to turn two fractions into one fraction. Now, let's talk about cross multiplication. This what we have up here, this is when you can use cross multiplication. Okay, so when one fraction is on the left and one fraction is on the right, you can then use cross multiplication. Now, before I continue, does anyone have any questions relating to cross multiplication and three-way multiplication? So everyone's okay?
Yes. So can I ask a general question?
Yes.
So is there ever a case where we have to use the three-way multiplication with three fractions? Or does it only apply to two fractions?
Okay, so if you have three fractions, what you can do is, so let's say you have A over B plus C over D plus E over F, right? What you can do is you can use three-way multiplication here for these two first. Turn them into one fraction. So you have AD plus BC over BD. And you have that fraction. Then you can use three-way multiplication again. This is a bit of a longer approach. So if you have 3 fractions, what I would recommend is to try and use your LCD method, to try and multiply or to try and find your lowest common denominator. That would be a faster approach. But if you struggle with that approach, I would recommend on the first 2 fractions, use 3-way multiplication and then turn it into 2 fractions. Then use 3-way multiplication again and turn it into 1 fraction. Okay. The student that asked that. Okay, awesome. Okay, so we were busy on example 4, right? So what I was asking earlier was, if we have a situation whereby we have 1 fraction on the left and 1 fraction on the right, are we going to cross multiply or are we going to use 3-way multiplication? What are we going to do?
Cross multiply.
That is correct. So we cannot use 3-way multiplication if we have, just give me a moment, please. Okay, so we cannot we cannot use 3-way multiplication if we have 1 fraction on the left and 1 fraction on the right. Okay, just to confirm, are you guys still able to hear me clearly and see the screen?
Yes, sir.
Yes.
Awesome. So from here, we're going to cross multiply. So we're going to multiply that 3 with the 1 on the other side. So we now have y plus 5 plus 3y less than 3. In addition to that, you can also add up the like terms. So we have that y and 3y. If you struggle with simplifying expressions, please go back to grade 9 and grade 10 textbooks. There's an entire section on the rules that are applicable when simplifying expressions. You can only add like terms, your exponent rules, your factorization rules. Those are going to become very important, okay? Algebra is used in every single topic. Keep that in mind. All of your math topics, you will use algebra. Any calculations that you do in physics, you will use algebra. So algebra is extremely important. Make sure that you understand all the rules. You can go back to grade 8, 9, 10, and your 11 textbook. The first 3 topics in most of these textbooks cover algebra. So just revise through them. If you go through the grade 10 textbook, you won't have to look at 8 and 9. So if you have your grade 10 textbook from last year, make sure you just go through the algebra component of it, okay? So from here, we have y and 3y. That is then going to give us 4y. I'm going to move that positive 5 to the right, making it negative 5. From here, we have 4y less than negative 2. Now, from this point, we need to isolate y. So we are going to divide by the coefficient of y. So we divide both sides by 4, thus leaving us with negative 1 over 2. And that is it. We've now completed example 4. Before we move on, does anyone have any questions relating to example 4? Keep in mind, this is still linear inequalities. We've not gotten to quadratic as yet. So does anyone have any questions regarding, or does anyone have any questions about example 4? Okay, so let us continue then. Now, let's have a look at quadratic inequalities. So with quadratic inequalities, keep in mind that when we are talking about quadratic inequalities, we are referring to whereby the degree is 2. So you'd find x squared or whatever variable squared, okay? Now, if we look at x squared less than or equal to 4, there's 2 ways that we can start. Option number 1 is we can square root both sides. Okay, that's one option. Option number 2 is we can move the 4 to the left and make it a difference of 2 squares. Okay, so That's option number 2. Keep in mind, you can find the difference of 2 squares or the difference of 2 cubes. You should have done that last year in term 1. That's part of your factorization techniques. It's important to understand how to factorize the difference of 2 squares and the difference of 2 cubes, okay? So which do you want us to do? Are we having a look at example 1, or rather, are we having a look at method 1 or method 2?
Method one.
Actually, let's just do both. I think we've got like 20 minutes left. Let's do both. So let's have a look at method 1 first, right? Now, with method 1, you square root both sides. So we square root the left and we square root the right. Now, square root of x squared, that is just going to be x, less than or equal to. Now, who can tell me what is the square root of 4? Where's an idea?
2.
And 2 is
Plus or minus 2.
Yes, whoever said plus or minus 2, that is correct. The square root of any number is positive or negative of that square root. So the square root of 4 is plus or minus 2. Square root of 16 plus or minus 4. Always remember that when you square root something, you have to introduce plus or minus. If you do not introduce plus or minus, it's as though you are excluding or you are forgetting one of the solutions, okay? So from here, we square root 4 and we end up with plus or minus 2. Now, when we are dealing with this, right, keep in mind we are talking about quadratic inequalities. So there's a few methods that you can use. I'm sure some of you have seen this method over here, whereby your teacher uses a line graph. I'm sure others have seen this method over here, whereby your teacher uses a quadratic function or parabolic function. And I'm sure others have seen the table method, okay? Now, I'm going to use the line graph. So from here, keep in mind quadratic inequalities is slightly different to linear inequalities in the sense that there's more steps involved, okay? So here, I'm not going to state x is less than or equal to. We'll call these our critical values. The critical values is what we put in our line graph. So from here, we've got our line graph. Now, we've got -2 on the left and +2 on the right. And yes, it is important as to which side of the graph you put them. You cannot put +2 on the left and -2 on the right. Keep in mind, I'm sure guys should have seen when you started integers, this line graph, whereby you had 0, then you had 1, 2, 3, -1, -2, -3, etc. So it's important to be able to understand which side of the graph your numbers are supposed to be on. If you forget or if you struggle with that concept, always remember that the smaller value is on the left or the bigger value is on the right. So -2 is small, so it's on the left. +2 is big, so it's on the right. Okay? Big right, small left. Always remember that. Now, who can tell me, when you are using your line graph, am I going to use a hollow circle or am I going to use a colored in circle? Who can tell me?
You're gonna use a colored in circle because it depends on the inequality sign.
That is correct. So always remember, if you have equal to, you color in the circle. If you do not have that equal to sign included, you leave out the colored in part. You draw a hollow circle, okay? So I'll repeat once more because it's important. If you have equal to, color in the circle. If you do not have that equal to sign, leave it empty. When we are talking about an equal to sign, I'm referring to this, I'll highlight it in red. Do you see that line underneath the inequality sign? Make sure make sure that you look at that, right? If there's a line under there, that means it's equal to. So you color in the circle. If it is empty, if there's no line under there, that means it is not equal to, therefore it is a hollow circle. In addition to that, if it is equal to, you'll use square brackets. If it is not equal to, you'd use rounded brackets. And when you are talking about it positive and negative infinity, it always has rounded brackets. So I'll repeat all of that once more. If there's an equal to sign, you color in the circle on your line graph and you use square brackets. If you are using this notation here, X an element of, okay, you use square brackets. But if you're not using this notation, then you don't really need to worry about the brackets. Then, if there's no equal to sign, you do not color in the circle on your line graph, and you use rounded brackets if you are using that notation we just discussed. In addition to that, always remember that infinity is always rounded. Whether it is equal to or it's not equal to, always use rounded brackets for infinity, because we do not know the value of infinity, so we cannot include it. So you always use rounded brackets for infinity. So now from here, our next step is to identify, are we going to go with the right, the middle, or the left? When I talk about right, middle, or left, I'm referring to these areas. This is the left in red. This is the middle in purple. And this is the right in blue, okay? We need to identify which is the correct area which will allow us to obtain our answer. So we need to choose a value that's on the right of 2, on the left of -2, and in the middle of -2 and 0. So let's start with the middle. If we look at the middle of -2 and 2, we have -1, we have 0, and we have 1. We can use any of those 3 values. You can even use the fractions that are in between, but I would recommend using an integer, not a fraction. It's easier. So I am going to use 0. Now, excuse me. If we look at the right of 2, we have 3, 4, 5, 6, 7, 8, 9, 10 till infinity. You can choose any number that's on the right of 2. I'm going to use 3. Now, we then need to look at the left of -2. We can use -3, -4, -5, whatever's on the left of -2. I'm going to go with -3. So these are the 3 values that I have chosen. 1 on the right, 1 on the left, and 1 in the middle. The reason that we are choosing these 3 values is because we are going to substitute them into the original inequality to identify which applies or which is true. Now, I'm going to attempt those 3 steps. When I'm done, then I'll ask if anyone has any questions, okay? So let us continue. So I'm going to start with 0. So when it is 0, we're going to substitute that 0 into x squared less than or equal to 4. If we substitute it, we end up with 0 less than or equal to 4. Then we need to ask ourselves, is this true? Is 0 less than or equal to 4? And we know that 0 is less than 4 because 0 is smaller than 4. That means this is true. Okay, I'll use a tick for true and a cross for false. So first we know that 0 is true, so 0 applies. Now let's move on to the next one. Let's move on to 3. So if we use 3, we substitute 3 into the original inequality, and we end up with 9 less than or equal to 4. Keep in mind, if you substitute 3 into x squared, you end up with 9, okay? So we ask ourselves, is 9 less than or equal to 4? We know that 9 is not smaller than 4. So that means this is false, it's wrong. Okay? Now, lastly, we are going to use -3. So we substitute -3 into the original inequality, and that gives us 9 less than or equal to 4. And we know that 9 is not less than or equal to 4. That is false. Okay. From here, we are going to draw a line in the middle. The reason we are drawing a line in the middle is because the middle value was the true value. 0 is in the middle. If 3 and -3 were the true values, we would have put arrows on the left and the right. Okay? So if your left and right are true, you put arrows on the left and right. If the middle is true, you put a line in between. Now, before we continue, does anyone have any questions with what we've done so far? Any parts that I need to repeat or something that you did not understand?
So can I ask a question?
Yes.
So whenever we deal with quadratic inequalities, like is it compulsory to draw like that number line, or is it just done just to assist us or to make things easier?
It's done to help you to find the answer. It's a bit difficult to go straight from the inequality to an answer, because if we had to solve this normally, we would have had x squared less than or equal to 4. From here, we would have had x less than or equal to positive or -2. So what this means is that x is less than or equal to 2 and x is less than or equal to -2, which doesn't really make sense, because if you were to draw a number line and try to understand that, it then basically means that the values of x is everything from 2 to -2 to -infinity. Why, if that was the case, would it not have made more sense to say x is less than or equal to 2? Why would we also have needed that -2 option? So like we're duplicating, we're making extra work. And if you were to attempt this, because x less than or equal to -2, choose a value that's less than 2. Let's choose -20, for example. -20 is technically less than or equal to 2, right? So if you substitute -20, I think that should be 400. Let me just double check. Yeah, 400. So 400 is not less than or equal to 4. So it's false. So you can see, without using some additional method, whether it's the number line method, whether it's your parabolic function method, whether it's your table method, you're going to end up with a wrong answer if you use the linear approach. That's why when they do this in your textbook, there's a clear demarcation of this is your linear inequalities and this is your parabolic inequalities. They would not have separated it if you use the same method for both. Now, you don't have to use this number line method. As I mentioned earlier, you could have also used, there's this method that some teachers use, whereby you draw a parabolic function. There's another method that some teachers like to use, whereby you use a table method, whereby you'll write the intervals, and then you'll use a trial and error concept of multiplying, etc. I prefer the straight line method. I feel like it's the easiest one. Take a value on the left, take a value on the right, take a value in the middle, substitute, see which is true and false, take the true answer. So yeah, you don't have to use the line method. Whichever method your teacher uses or you find easier to understand, I recommend using that. But yeah, there has to be some method that you use beyond the linear approach. If you use the linear inequalities method, you are going to get an incorrect answer. So before I continue, does anyone else have any questions?
Hi, sir. Can I ask?
Yeah. Yes.
So, sir, let's say -3 was true. How would we draw the line?
-3. Okay. So let's say -3 was true. Just give me a second to copy this. So let's say this -3 was true and +3 was true, right? Both of those are true and 0 was false. We would just draw an arrow in those directions. So yeah, if -3 and +3 were true and 0 was false, this is how it would be represented. So you can see the difference there. So if the middle is true, you draw a line in the middle. If the left and right are true, you draw arrows left and right. So yeah, that's it. Does anyone else have any questions? Yes.
So can I ask a question regarding the
Yes.
Oh, okay. So the question that I had is with the example that we just did now of the -3 and the 3. So doesn't like the arrows in a way indicate that any number from -3 to infinity can be true? Or how does it work, sir?
So with the arrows, the reason that I like to use this linear method instead of using the table method and instead of using the parabolic function method is even if you don't understand the concept of the inequality signs, let's say you get confused by them. Even if you don't understand which is less than or which is greater than, copy the arrow. This linear method shows you the arrow, which is then the inequality sign. So here, do you see the arrow is pointing left here on the left? So copy this arrow left. That's your answer. So this is your inequality sign. Bring this down, and your answer is x less than -2. Don't forget to put the equal to because the original question had equal to. Then look at the arrow on the right. Copy that arrow on the right, and then just bring it down. This is your answer. If positive and -3 were the correct solutions. So all you would need to do is, even if you don't understand what this line graph means, you don't know what greater than 2 or less than 2 means, or you don't know how to represent it, copy the arrows and you'll be fine. You'll get the marks. It's correct. So that is if you are moving right and left. Okay. Don't forget your answer has to have the critical values. You don't use -3, 0, and 3. Your answer must have the critical values, okay? Before we go back to our solution and finish up, does anyone have any questions relating to what we've done here in this bottom example?
Yes. So in this
sorry,
case,
sir. I just wanted to ask.
Yes, whoever was talking, yeah.
So in this case, we would have two answers.
Yes. If you're moving right and left, that means you have two answers. If you are in the middle, you have one answer. So the solution, if it was in the middle, let's actually go back and finish the first answer, then you can see. So -2 and 2. Always copy this as is, the signs here. They must always, the opening must always be to the right if it's in the middle. It can never face to the left if it's in the middle. So the middle, the signs must always open on the right. Whereas if it's moving right and left, if your arrows are right and left, just copy the arrow. Whereas if it's in the middle, memorize this. Just memorize this over here for the middle. Then there was a second person that was asking a question. Okay, so everyone's okay. No one has any other questions?
Sorry, sir. Sorry, sir.
Yes.
I was asking in terms of the exams, will they ask whether we should use for the number patterns, will they ask if we should use the parabolic graph or the number line? Will they ask whether to use them or we can use any of the two?
And you can use any, it's dealer's choice. You can, yeah, whichever method you want to use, you can use that. They won't restrict you on what you are allowed to use as long as you obtain an answer. Because keep in mind, you'll only get 1 mark for this. Your answer, you'll get like 2 marks. 2 or 3 marks, depending on how difficult it is. You'll get a mark for your critical values in your answer. That would be this positive and negative 2. And you'd get a mark for the signs being in the correct direction. But yeah, you are not limited to which method you can use. You can use any method. Does anyone else have any questions before we move on? Okay, then let us continue. Basically, if you want to read this, right, on the left, we've got x less than or equal to negative 2, meaning that anything from negative 2 all the way to the left to negative infinity is correct. And on the right, we have x greater than or equal to positive 2, meaning that everything from positive 2 until positive infinity is correct. This is one notation. An alternative notation, I've noticed some people like to use this notation. You can state x an element from negative infinity until negative 2 union from 2 until positive infinity, okay? So this is an alternative notation. Whether you use the first notation or the second notation, that is completely up to you. You will not be restricted. In the memo, you'll actually find that both notations are on the memo, so you can use whichever, okay? Then if you are using this first option here, the notation that you'd use is x an element from negative 2 until positive 2. Take note of my brackets. You'll see that because we have equals to, my brackets are squared. However, by positive and negative infinity, my brackets are rounded. As I mentioned earlier, positive and negative infinity, we don't actually know what the value is. So in math, we always use a rounded bracket for positive and negative infinity, okay? So yeah, just give me a second to clean this up, then we'll go back to the actual question. Okay, so from here, right? Like I mentioned earlier, when you are dealing with the middle, always memorize the direction of that inequality signs for the middle. The opening must always be on the right, okay? Then, when you are dealing with the right and the left, if the arrows are on the right and the left, just copy the direction of the arrow. Then an alternative notation to this. So you can either have this as a solution, or you can use this, x an element from negative 2 to positive 2. Whether you use the first notation or the second notation, you'll be marked correct. It's the exact same thing, okay? So this is the first method. Now the second method I was talking about, I'm not going to go through the full method because I actually want us to do one more example on quadratic equations as our 1 hour is already up. I'll just quickly show it to you. So here we had x squared less than or equal to 4, right? Now, if you want to use the second method that I spoke about, that is your difference of two squares. What you are going to do is you're going to move the positive 4 to the left, making it negative 4. And this is what is known as a difference of two squares. The explanation is in the name. Difference, meaning subtraction. Two squares, meaning two squared terms. X squared, and 4 is a squared number. 2 squared is 4, right? Difference is that negative sign in the middle. So if you want to factorize a difference of two squares, you square root the first term, that's x and x. Square root 4, that gives you 2. One must have a positive, one must have a negative. And from here, your critical values will be negative 2 and positive 2. Exactly the same as what we had earlier. So it's a bit of a longer method, but it is an acceptable approach to use. Okay. Before we move on to example 5, does anyone have any questions relating to, or rather before we move on to example 6, does anyone have any questions about example 5? So everyone's okay. Awesome. So let's move on to example 6. I want us to do one more before we end. So we did something whereby we have a solution in the middle, right? Let's hope that this is a solution on the right and left. I want us to do one with the right and left. So we have example 6, right? This is a trinomial. You've got x squared, you've got x, and you've got 6, right? Now, the same rules as equations applies. When you have a trinomial, always make it equal to 0. That is a rule. Anytime you have a trinomial, whether it is inequalities or it is equations, anytime you see a trinomial, always make it equal to 0. That means this 6 has to go to the left. So that will then make it x squared minus x minus 6 less than 0. From here, we need to factorize. So I'm not really going to go through the steps you need, but yeah, this is what it would be if you factorize it, okay? Always remember, when factorizing, find the factors of the first term, the factors of the second term. Sorry, the last term. The factors of the last term, when added up, should give you the middle term. So factors of -3 and +2 give you -1, which is the middle term, okay? But I'm not really going to go into detail regarding that. I would recommend look at factorizing trinomials. You should have learned that in term 1, grade 10. So go back to your grade 10 textbook, go to factorizing trinomials, you'll find that there, okay? So now that we've factorized, who can tell me what our critical values are going to be?
So it's going to be, isn't it going to be +3 and -2?
That is correct. -2 and +3. Now, question might be asked, how did we find those critical values? We find them by just solving for x on the side of our page. So rewrite the equation or rewrite the inequality as an equation, right? And then solve for x. When you solve for x, that will be your critical values. So when you solve for x here, you get x equals 3 or x equals -2. Those are your critical values. Always remember, after you factorize, write it as an equation, solve for x, those are your critical values. If you don't need to write it out and you can already do this step in your head, that's even better. Okay, now let's draw our number line. So which is going to be on the left and which is going to be on the right in my number line?
-2 is going
-2 on the left.
-2 is going to be on the left and 3 is going to be on the right.
That is correct. Am I going to have colored in circles or hollow circles?
Hollow circles, sir.
Colored in
Hollow
circles.
circles.
That is correct. So because there's no equal to sign, we don't color them in. Now we need to identify a value in the middle, a value on the left, and a value on the right. So in the middle, we can go with 0. Anytime you have the option to use 0, I recommend using it. It's the easiest to work with. Then on the right of 3, we can use 4. And here on the left of -2, we can use -3. Okay. Let's actually use -4. That way we have positive and negative of the same thing. Now, from here, we need to substitute 0 and positive and -4 into the original equation and identify if it's true or false. So let's start with 0. Now we substitute 0 into the equation of x squared minus x minus 6. Just give me a moment to move this to the side. Okay, and that is less than 0. From here, if we were to substitute, we would have 0 squared minus 0 minus 6. So we have -6 less than 0. Now, Is that true or is that false? Is -6 smaller than 0?
That is correct, sir.
That is correct, yes. So -6 is smaller than 0. I did not want us to have it in the middle. I wanted us to do something whereby it's on the sides, because we already did an example with the middle here. Just give me a second to change this so that it can be on the sides. Yeah, let's do it like that. So it should be on the sides now. So let's just attempt that. So here, because I want us to just use the two notations. That way, when you refer back to this later, you can see the difference between when it's in the middle and when it's on the sides, okay? So what I've done is I've just swapped the inequality around, okay? So from here, now I've changed the inequality. So now it is -6 greater than 0, okay? Now we know that -6 is not greater than 0, which means this is false, okay? Meaning that it's not going to be in the middle. So let us attempt using -4 and +4, okay? Now the reason I changed it is because our session time is already up. I just want us to do an example with both before we end, okay? Now, from here, let's attempt it when it is +4. So we'll substitute +4 into this original inequality. So it's then going to be +4 squared minus +4 minus 6 greater than 0. If you put that into your calculator, that's going to be 16 minus 4 minus 6. That gives me 6. So who can tell me, is this true or false? Is 6 greater than 0?
True.
Yes, it's true.
That is correct. So we know that 6 is greater than 0, meaning that when we go to our number line, we are going to draw an arrow in the right direction because 4 is a value on the right. Okay. Let's try -4. So if we use -4, it's going to be x squared minus x minus 6 greater than 0. From here, we have -4 squared minus -4 minus 6 greater than 0. We can put that into our calculator. So -4 all squared minus -4 minus 6. That gives me 14. So is this true or is that false?
That's true.
That is correct. It is true. So 14 is in fact bigger than 0. So because 4, or rather -4, which is the value that we used, is on the left, we draw an arrow to the left. Okay. I'm going to write out two options. You can tell me which is the correct one. Is it going to be x less than -2 or x greater than 3? This is option number 1. Or is it x greater than -2 or x less than 3? Sorry, 3. So is it option number 1 or is it option number 2? Which is the correct answer?
Option number 1.
That is correct. We would use option number 1. Now let's discuss why we are going to use option number 1. Just to confirm, is everyone still able to see the screen? Okay.
Yes, sir.
Awesome. So how did we arrive at the solution of option number 1? So what we are now going to do is we're going to look at these arrows. So let's look at the arrow on the left first, okay? So if you were to copy the arrow direction, so you write X, you copy the arrow, and then you write the critical value. That's it. if you notice, the arrow and our inequality sign are identical. They're facing the same direction. You do the exact same thing on the right. So write X, copy the arrow sign, and then write the critical value. That is it. If you notice, the arrows are identical on the left and the right to the inequality signs on the left and the right. Okay. In addition to this, you can write a secondary notation. So you can also use this notation, X, an element from -infinity to -2. Now here, by this -2, am I going to use a rounded bracket or am I going to use a squared bracket by -2?
Rounded brackets.
That is,
Rounded
no.
brackets.
Rounded
Yeah.
brackets.
Rounded. So we'd use a rounded bracket because, now that's the reason we color in the bubbles and not color in the bubbles. If you color in the bubble, use a square bracket. If you don't color in the bubble, use a rounded bracket. Alternatively, if you don't want to work on the notion of color in, do not color in, you can use the inequality signs themselves. Go back to the original question. Look at the original question. Identify, is there an equal to? If there is an equal to, square bracket. If there's no equal to, rounded bracket. Always remember that. If you find the concept of rounded and square brackets difficult to remember, just use the first notation. Get the same marks as a person who used the second notation. And you don't even have to write both notations. As long as you write one of them, you'll be fine. So you can either write this top part or you can write this bottom part. Whichever, you don't need to write both. But yeah, for those that like to use the bottom part, let's just finish up the second notation. Then you'll write union. And now I'm not going to put in the bracket. I'll leave that to you. So we have 3 positive infinity. Yeah. So by the 3, do I use rounded or squared?
Rounded.
Yes.
Rounded
And by that infinity,
Rounded.
rounded or squared?
Rounded.
Rounded.
Yes. Always remember, infinity is always rounded, whether it's inclusive or not inclusive. Infinity and negative infinity are always rounded. So that is example 6. Keep in mind it was changed. So if you were writing on a piece of paper, make sure that you changed the original question as well. I changed the direction of the sign so that we could have something that's on the left and right, as I wanted something different to example 5, okay? So we'll end here for today. Before we end, does anyone have any questions relating to example 5 or example 6? So everyone's okay. Awesome. What I will do is I'll post this PDF in the group. You can try out example 7. You can try out example 8, as well as example 9 and example 10 on your own. If you get stuck, you can take a picture of your working out, what you've done so far, send a message in the group and just say, I'm stuck by line number 6 or line number 2 or whatever the case is. If you want confirmation on whether what you did is correct or incorrect, you can post your working out in the group and then I'll just confirm it's correct or it's incorrect. Fix this, fix that, whatever the situation is, okay? So, yeah, we'll end here for today. Then those that are attending next week, I'll see you next week for whatever it is that, whatever topic is next week, okay? So yeah, thank you guys for attending and bye everyone.
Bye, sir.
Bye, sir.
Bye, sir.
I see.